What are the technological trends you have observed in media processors in the last 6 months?
So actually the media processors are also changing the way they were being deployed in past. It was only considered as the C experience, as the consumer and then the electronics, that's the C experience. However, these media processors are getting more and more deployed into the automotive domains as well. And as we look into the automotive domain, this media processor becomes very, very important because it has to collect a lot of information which is being picked up by these sensors and cameras. So the media processor would need to have the interfaces and dedicated hardware blocks in addition to the dedicated processing blocks and a security aspect on top of that. The moment any images and signals are received from cameras and sensor, these need to be processed in real time, fast. These have to be again checked and validated so that there is no false alarm or false information. So that security layer is built in actually. It's validated, and then out of this the conclusions are made and displayed to the driver basically. So the media processors are definitely increasingly getting deployed into the car electronics, particularly the infotainment. So it's the cockpit cluster which is more important actually here. That is going a change because now you have more and more possibility of the processing of the signals. It's not only a question of the radio that is being received or a cassette that is being played, but more of the video processing as well, but also taking the real-time signals, what's happening around the car. And that's why the hardware blocks are very, very important.
Okay.
So it takes this all platform development, taking it from the C experience as a perspective, but at the same time, build that robustness that is important for the automotive experience. Going forward, the similar things will continue, and we expect that the clusters, the display panel in the car, that will also undergo a change. It's not only a simple dashboard display where the pointer is moving and the speed and a kilometer and a mileage, but now, depending on the user requirement and the situation requirement, this display will change actually. So it itself will become a reconfigurable, reprogrammable, and that is where the media processor again, engine, the strength and power of that would be very, very important actually.
So with larger customization, every processor will be more powerful is what you feel?
Yes, so it's not only more and more powerful actually, but what is important is the reliability. So these chips would get tested for reliability, and these chips are targeted particularly for automotive segment. They would go for that AECQ qualification as well as the temperature grading and profiling. And building those desired hardware blocks on the chip, because things have to be done in the real time. Typically in the DSPs, you get the data and you process actually, there is a latency or a lag. But here in this case, if let's say for example there is a camera, you cannot afford a lag because the camera, whatever image it captures immediately in real time, it has to come, and driver should get assisted by what's happening outside actually. So it's a real time processing is what is more important.
So in today's world, what is driving this influence? What is causing this change, tide of change to happen?
See, particularly the world is looking at electronics as a way for innovation in the automotive. So gone are the days where car was considered to be the still body with 4 tires, 1 engine and few seats and a plastic. It's gone. It's there still obviously. It can go for styling, look and feel, and all those things are very, very important actually, that continues still. But the key innovation in automotive is coming from electronics, which is enabled by semiconductors and software. So electronics, semiconductor software, the strength of that and the power of that and the capabilities are helping to create the additional innovations. So ideas were there, it is no big deal. I mean today if I'm driving a car and there's a truck running in front of me and there is another car running in front of truck, my wish list 20 years ago was, if that car puts the brake, I should know about it, but I cannot see because there's a truck in between actually. And technology was not ready to implement this. So need was there, requirement was there. Now technology is available with this vehicle-to-vehicle communication, for example, which is again an innovative approach. The moment the car puts the brake in front, that car communicates to all nearby area in the range of let's say about 300 meters that I am braking. Now human being takes time before they see and then apply the brake, but the system, as soon as it gets a signal, it's again security enabled so that it is authenticated that it is the right signal and not a false alarm. And the driver knows now, and the vehicle knows that there is a car in front which is putting a brake and there is another car or a truck behind which is also going to brake now, so better you brake. So that is a technology which is availability that makes a difference. And that is why we see that this is really getting into a change, basically how we do.
Okay.
And this is a broader concept of called advanced driver assistance system. There are many other things actually along with this.
Okay.
When you talk about, say, you're going on a road, you have one car, you have the other car. One car is braking and you say it's going to be automatically communicated to
Yeah.
vehicles within 300 meters.
Right.
So for that, all the vehicles in the road have to be pretty much connected to one another.
Yeah.
Right, so that should be some instantaneous process. As you move, the vehicles that come in that area, you'll have to connect. So establishing that connection will take some time.
Yeah.
So that is one problem that will be there.
Yes.
And there will also be a problem of you should be careful about what signals can be allowed to control.
Right.
So how do we approach this particular aspect? One will be connecting on a real-time basis.
Yeah.
So what are the features that will
So
enable?
it surely you rightly pointed out, there are, let's say, maybe about billion cars on the road today worldwide. Maybe India about 40, 50 something. All of them do not have this feature enabled. So right now people have been thinking about it, so this will get deployed in future, what happens to the existing cars. So some of the aftermarket attachments and accessories would come up. The moment the standards are set, already there are some standards such as DSRC, right? Dedicated short range communication. It's the up to 300 meters signal transmission going at a frequency of 5.9 G. So the standards have already been set. Like that, there are one or two more actually, depending on country to country, different things can go. So first process is always to establish the standards, define the protocols and the signal mechanism, so that the cars, when they are communicating, they know what's happening actually. Like a language, I'm speaking and then the English is understood, Hindi is understood or Kannada is understood. So that's a language they need to understand. So those all standardization of the protocols, communication, frequency, decoding has already been established. It's already there. Now it's a question of implementation, which happens. So for car-to-car communication, it's going to take time, but there is one intermediate step which is happening and that will also be important as an overall thing, which is called car-to-infrastructure communication. So now you will have the infrastructure and you have a car, so there is a communication between car and infrastructure actually going on. So infrastructure is what? It's some kind of a pole side unit or some kind of a tower unit or put into the building actually. So all these information exchanges is happening actually. When it goes to infrastructure, from infrastructure through the big data or a cloud computing, it goes somewhere else in the air and again comes back to the next vehicle actually, which is most of the vehicles would be enabled by either radio, which is already there today, or tomorrow LTE, which can also happen, or the people who have got the cell phones. So if there are some accidents on the road, just an imagine the example, there is an accident about 200, 400 meters ahead and people are not aware. So at least if something happens in car to infrastructure, infrastructure to cloud, and there are some service providers which will broadcast the signal back. And then that's how, the people would come to know what's happening over there. So these are some intermediate stuff which will come in. But definitely there is a big market which will emerge for the aftermarket attachment, simply because there is a lot of population of the cars there. And just because somebody likes the technology, they are not going to throw away their cars.
So it's kind of like improvements in the field of automotive will go hand in hand with smart city developments.
I would say the smart city development is much larger picture actually right now.
Correct. Right.
And also there are various definitions and various connotations people are looking at. Everybody has his own way of how they call smart city. Like somebody was saying that, city should be livable. And I was joking, today every city is livable, come on. You cannot say that city is not livable because there are 10, 20, 50, 100 million people staying in various cities in the country. City is livable, that is not enough. There is something more which is required. And so in smart cities, the way I would expect is basically there is a lot of additional infrastructure that would get created. That infrastructure is, for example, just a very simple example. If you look at today, these cities, the lighting is always on or always off. Sometimes you make it automated, or there is somebody who pushes the button and it is on, or he forgets, then the whole day light is still on actually. And in some cases, maybe light may not be required during night because there is nobody which is on the road actually. So there is a concept which is called as a smart lighting. As the vehicle moves, at one particular node it is detected, and then these all poles are connected by a mesh network. So that signal gets transmitted and the entire thing can light up actually. Or if the activity is less, the light can get dimmed actually. So these programs can be done. And the entire thing will become a mesh. So the way we see actually, there will be a lot of infrastructure which will become smart. So smart lighting, let's say one example. Then the vehicle to infrastructure that would come up into the smart cities. That communication will happen actually.
Right.
So the expectation is today, when we look at the IoT, which is being talked about actually, where connected devices, and you take various reports and people will say in 5 years, 40 billion or 50 billion or 60 billion devices would be connected. Doesn't matter what number, it's a huge number.
Right.
Devices are getting connected. As these devices are getting connected, those will become smarter. They will have additional intelligence. they will have additional processing power. So that's the connectivity and the smartness would be a direct going hand in hand. And the way we envisage now as a next step is, if the things have become smarter, the next step is most important, is going to make it secure. Today people are not thinking too much about that actually. And security will become important because it's connected and it is smarter. So if the intelligence is there, you can build the security now. Otherwise, if security is not building, it is vulnerable to kind of a false events and false attacks. And I'm not saying that people have got a wrong interest or wrong activities, but it happens actually everywhere. Particularly we see in India, there are many people those who would like to twist the system or bypass the system or do something hanky-panky stuff. So whether we like it or not, we have to face this reality, and that is why anything what we create now as a connected approach will need to be secure.
Okay, so there are devices right now which have embedded security inside them. For example, some printers, some companies with printers are also having chipsets which are having security inbuilt into them. Won't you think inbuilding such security options or standards into what you spoke about will be the next stage of development, and then it can drive?
Yeah. So what would happen is now we look at a concept of the smart home and a smart office. So within home itself now, you will have going forward everything which is more of connected home and a smart home. And that means anything, all those devices, the lights and bulbs and fans and tubes and air conditioners and microwaves and fridge, those are talking to each other. These all need to communicate, and when they communicate, there also need to be security so that again the false alarm should not come. Otherwise somebody from outside gives a remote alarm and then your door is already open, right? So you need to ensure that security aspects are established so that whenever these subsystems are deployed, they have a proper security device which authenticates the person or a device which is giving a signal. So if device A is giving a signal to device B, that is the outside key is giving a signal to a lock that I am a key, please open the door. Now they have to authenticate and make sure this is the right key for a right lock. And that is what we call as security actually. The moment it is authenticated and verified, then the door will open. And then it opens for only the person who is the right person actually. You see already this has been established into just an example, into most of the cars in India. So today if you look at the cars in India, I think almost all cars are coming with a concept called immobilizer, or they call it, you see normally a mechanical key, but behind the key there is a flash and there is one electronic RF chip inside that, which is used for calling the concept called the immobilizer. So if somebody takes your key and duplicates, because you see a lot of roadside units, within a minute they will take your key and give you another mechanical key ready. You make that and still start the car, it will not start, because that RF chip which communicates with the base station within the car to authenticate that I am a right key is missing. And you look at today, and for example NXP, who have been advocate of this concept, last 15 years we have been doing that worldwide. Almost 9 out of 10 brands worldwide, they use our chip for the RFID key. And in India, almost 80% of the cars are using NXP chip right now for immobilizer, the RF chip. Almost all brands you will see actually. And if you track the data of the vehicle thefts, year after year it has gone down. If you look at it. And I personally asked a couple of car makers, because they get the complaints normally, and they say that the amount of car thefts have gone down substantially now after this kind of keys have been implemented. So that's how it helps actually. So it's a little bit extra cost, but for a car, if you are paying let's say a few hundred rupees more and you are securing your car, why not? Everybody would like to have it actually, and that has happened, the major change in the country. And many people are not aware, by the way. You ask today, out of 10 people, 5 people won't know that their car has got a RFID key and it is already immobilizer and it is a secure car. But it's a secure car actually. It's already secure car in the sense for a starting perspective. But there are several other things that will also come in. One by one it will come actually.
Yes.
But that way.
Talking from a chip perspective, so you mentioned one was this RFID thing that's being implemented at the chip level in order to safeguard your automotive aspect of things. So in that sense, from a chip level semiconductor point of view, what other innovations or inventions have you seen in the last 6 months in the automotive sector particularly?
So what we see is I go back to the same statement again, that we strongly believe that in automotive, 90% of the innovation will be done by electronics, enabled by semiconductor and a software. So at a chip level, there is a more and functional integration which is happening. So give you an example. Now recently we launched one chip for the radar. It's a stamp size, small chip actually. Operates at 77 gigahertz as a frequency band, as a standard and approved frequency band. And it can be configured for a low or medium or a long range. Now once you use this single chip device, the space constraint is no more there. That means I can put this now radar at the back, on the door, right or left, doesn't matter, or front, which was not feasible, let's say 2-3 years ago. I wanted a big system actually, a big board, so I can put it either on the back, somewhere, or maybe front, and then it's difficult to put on the door because there's no place available actually. So all these innovations are particularly moving towards putting more and more functionality into an integration aspect, building more and more functionality that is application specific, and from that chip then moving to the solution provisioning. So once the chip is ready, then you make a solution. Solution for what? I do a solution now for lane departure warning. So I am, if not in the lane, in outside countries, it is most important topic. I do now a solution which is for rear view camera. So I have a radar which captures the information, again image, and then I bring it back actually here. I bring the solution which is for the door alarms actually. If something is very close nearby, or some dash or something is going to happen, you get an immediate alarm and image signal. So what you do is more of building those chips with the desired hardware blocks, creating more and more of integration by using the process know-how and IPRs, and make a solution out of that for specific applications and requirements. So that's how the trend is going, and it will continue. It's a chip which is going to really make a big difference onto the automotive electronics. That's pretty clear actually.
Okay. What do you
And that is where, as a NXP as a company, along with Freescale, which are our merged partner, we have been spending a lot of efforts here. And as I told you initially at the beginning of the discussion, that we have, let's say, more than 11,000 engineers worldwide. What they do actually, they do all these things to look at how we innovate, how we bring more and more different technologies and perspectives together to get integrated stuff, more application-specific devices, smaller footprint devices, and then building those solutions which can be taken by the customers for faster time to market.
Okay, so going forward, do you think the modular devices will be the next stage of chip design? Things are getting shrinking, and we have modular cell phones. Everything is just getting modular. So what is your take on that?
My view is it is model in a chip perspective would be defined from a solution perspective. So you will define a solution. For example, I define a solution for infotainment. So I will define a solution for a very high-end infotainment or a normal basic infotainment. And for that, there will be various modules that would be designed. Interconnect and communication methodologies would be standardized so that you can pick and choose, put it together, and then you are faster into the market actually. But that would need some more time. But the industry is moving towards that as we. And it's mainly because of the concept of the shrinking the cycle time. Every customer is looking at, when I start, can I do it fast? Because that's what the consumer expects actually. And this is driven mainly because of the consumer electronics devices where you have to launch and you fast in the market and get into the new one. Similar concepts are coming towards the automotive side also. So it is more of reconfigurable, retargetable devices. That's where the modular concept would be very, very handy. If you look at the automotive space, for example, when you were starting the automotive guys, when they start the design, they decide the SOP, that is the start of production. So when they start today, the start of production is 2 or 3 years away. In the 2 and 3 years away, sometimes the customer needs and requirement might have changed. So by the time they launch, some of the functions may not be relevant at all. You look at some of the very high-end cars, those are coming with the navigation systems into the car. Many people later on stop using those navigation systems because the maps were outdated, those were not usable at all, and people had phone with some other fancy maps, those are updated every day with real-time traffic alerts, everything. People started using that. So now we have to look at a concept where the designs are more adaptive, so that you start today, but as the automotive car is getting completed actually in its design cycle in 2 to 3 years time, you are able to change. You need to have flexibility by reconfiguring that hardware block or module, remove and put another one over there, and they adjust that software so that it is adapting to that need actually. So it is all adaptation which is going to become very, very important, and that is where this modular concept, either in the form of multiple chips and modules, or which we commonly follow, is the modules or blocks. Those are designed actually. So today if we have to design a chip, we have a library of blocks that are already designed. We then pick and choose multiple blocks, do the integration at a chip level, validation testing, and get quickly into the market. There is no right scratching from the scratch pad that every signal or every transistor doesn't get redesigned actually. So modular concept is already being implemented at a chip design level.
In fact, talking about that you would probably call an IP, right? You
Yeah,
already
very
have
IP blocks and library.
Exactly. So when
library.
Yes. So in one of these interviews that I was talking, they mentioned that okay, designing an IP is a very big thing. So that is done. But then now with so much innovation happening,
Yeah.
are we almost at the end of say an IP creation stage? So everything that we need is already there. The major parts. It's all more of a tweaking and putting together things together kind of thing. So are we at the end of like IP major basic creations? Are we at the end of that stage?
No, I don't see that we are at the end of the stage of the IP, particularly because still there are various domains of the life of the people, individual and society. Newer and newer ideas are getting generated and these are getting implemented. So you might have some of the IPs available but not all. I just took an example of let's say 77 gigahertz radar. Now that IP was not there 3 years ago actually. But at the block level maybe I had an IP of RF communication, maybe I had an IP of how the data goes and back, I had an IP of how the data authentication happens, not everything actually. So these incremental things would still be there, and sometimes the existing IPs may not be good enough to tackle the needs of future, so that's where the breakthrough will come and the new IP would get generated, right? We had a light, so light was a simple incandescent bulb, let's say that was the IP. Later on the tube light came, totally changed, right? Bulb small, tube light so big. Then in that tube light people changed to the smaller one or a smaller sign, thin and this. So that's the incremental innovation. Tube light people replaced by CFL. CFL 7 watt, 8 watt, 5 watt, 15 watt, 2 rods, 3 rods, twisted rods, these are all incremental IPs. Now that is gone and you have a LED bulb, right? It's altogether a different IP. So IPs would continue to be required actually. As the time changes, requirement, different things are required. Few things become feasible also as the time progresses. So LED bulb, which may not have been feasible 30 years ago, maybe Thomas Edison might not have imagined that there will be a LED bulb actually, right? Today it is visible. And even as early as last year, even in industry people were not expecting that LED bulb prices will go so low, that you can replace everything now. But things have changed. Today you look at there is a huge change which is coming because that LED bulb is also as good as your CFL bulb now. Maybe a little bit more. 100 rupees CFL, 150 rupees LED bulb. People are going to change. Because they see the life is 5 years, 10 years and all those advantages, power consumption and everything. So this will change. Like this there are some more examples. And particularly as I was discussing about automotive, there is more and more thing which is going to happen in automotive actually. So that is automotive today people think as the smart home from away from home. So you are home and then your away from home is sitting in the car. And many cities, not only question of Bangalore here, people spend 2 years, 4 hours into the car. In many cities outside, people for 300, 500 kilometers, they just drive the car actually. And as they do that, they need something more in the car. So it is not only question of the driving comfort, but also the various safety, advanced driver assistance systems, radars, connectivity, so that every time you are absolutely connected to the whole world. This is what is going to happen actually. So these IPRs would get created. There is no end to it actually.
Yeah, self-driven cars.
Yeah, self-driven cars people are talking about now actually. Self-driven cars are talking about then you put 5, 6, 8 sensors around and then your car, self-driven car is there actually. Which is going on. So if I go to the office every day, spend let's say 2-3 hours as an individual and getting strained. I know there is always a traffic, still I say, hey my God, there was a traffic today, too much traffic. But I know yesterday was also traffic. Day before yesterday, last month was also a traffic problem actually, right? Now I have a self-driven car, I am sitting, I am doing my work also and then just watching. If required, I intervene, otherwise it's going on actually. So this will come on actually. It's a big topic, self-driven car. Now recently, we have been working on one project, for example, and I'm involved into that at Singapore actually, called Nanyang Technological University, NTU. So there we have created a facility called the test bed for the testing of the vehicle to infrastructure and vehicle to vehicle communication. So entire campus is now getting implemented with 50 roadside units and other stuff. And we are telling now to the industry that anybody wants to test these concepts of vehicle to vehicle, vehicle to infrastructure, there is a facility, test facility available. Go and work with the university and do it. Or if you want to sponsor some research projects, go and work with the university and do it actually. So this is how the expansion of ecosystem is also happening. And the moment it is there, and many other companies or startup community or professors they start to do, what they will do? They will do some more innovation. They will come out with some more idea. They will apply it somewhere else. That's how it will move.
Okay. And then I was going about smart grid, the smart cities. There is some concept called where you help disabled people find their way I think the chipsets for tracking can also be built with this technology. What's your eye on that?
Yeah. So actually, we had some experimental concept already done where the disabled people get the guidance actually. So obviously what you will have is radar-based kind of a chips first thing, that it senses what is around, and then connectivity through the infrastructure, let's say, so that concepts of what is vehicle to infrastructure I was talking about also applies here. So assume that stick is a vehicle, let's say, may not be moving fast, it's slowly moving. So from there the data goes into the roadside unit, RSU you can call it, and the signal goes, and that roadside unit has got already a lot of data pump available as what's happening and around, and there is a camera, which is just an example scenario, there is a camera which is observing what is going on around, signal back and gives to this signal back to the disabled person, which let's say is not able to see anything, but then his stick has an idea where to move, and it starts to give the direction based on the either vibrations or the some kind of a voice enabled command that move or stop a little left or a little right, or stick start to turn a little bit because there is a little bit DC motor actually, so it starts a little bit and then the guy knows that now I have to turn right. There are various ideas which would get implemented actually over here. So we see that clearly the technologies which you use for one domain can be reapplied and reused for other domain as well actually. So this is one aspect. Then if there are people who are disabled, they cannot move and they cannot, then you have those automated vehicles which you talk about, you can bring it onto your automated wheelchair actually, which is similar to automated vehicles actually. There's no big difference, right? So you have the signals around and then you monitor and watch and then you start moving, or by vehicle to vehicle communication, this wheelchair gives a signal to the another all vehicles around that I am a disabled person, I am on a wheelchair and I am now start to move, please stop, and everybody stops, right? So similarly we see one example actually which we have been experimenting, that usually what happens is when there is a school bus which is moving, typically school bus stops, what happens is many the kids, they will come out from the bus or they will go inside the bus. So the moment it's a school bus, it could send a signal to the nearby infrastructure, and vehicles know that this is a school bus actually. That means if it is a school bus, means what? There will be kids around, there will be children around, so be careful now. So the guy knows, the driver knows, or the vehicle knows that now I have to be careful, and accordingly they try to be a little bit slow or be careful in terms of monitoring where the kid is coming and where is going on actually. That's another example. The third example and experiment which we are trying to do actually was very simple, that let's say there is a ball, suddenly the vehicle is moving and the camera detects a ball. Now what happens after hitting the ball? There is a process. If it is a human being, he will know, oh, ball, or this is a ball, that means some kid is playing around or somebody is moving around and somebody will jump now to correct the ball. So I need to be careful actually. Now this is human being, we know. Same intelligence we can build, and I was saying that there is a more and more intelligence, smartness into the devices. So your radar which detects there is a ball, and there is an intelligence which detects which kind of ball is this, and then makes a guesstimate that, oh, maybe somebody is going to leave the ball now, be careful, and then you watch that actually. And they accordingly signal. So this is how the concepts are there. Now these are all innovations and some ideas, and I just put forth some of the thoughts actually. Obviously there are hundreds and thousands of people around who are playing around with the technologies, and there are a lot of startup community, and they are looking into this kind of concepts and ideas, and you will see that in the next few years many such solutions would begin to emerge. People would use that technology, apply the innovations, build the business cases out of that. So in the process, the overall society would get benefited, and there are some small startups and other companies, they would also get a benefit of the business they create actually.
Certainly paints a very good vision for the future, I can say. There's one question, I mean, a lot of these things, now it's moving towards motion based. Either it could be gesture based, it could be say a moving ball which you spoke about. So when you're building a processor for that kind of an application, so this will come in, I think, a little motion based and real time, both kind of will come into the picture here. What challenges would these kind of things introduce into the design perspective from a processor design?
Right. So what happens is the most important thing is, challenge here is the business case analysis, whether to do such a chip or not. That's the first thing.
Okay.
Right. So the ideas are there. Now whether this idea, whether it would be really required in a mass scale, or let's say it would be required for a section of the scale somewhere in the country or somewhere in the world, make a first conclusion as what is that would be required over, let's say, next 3 to 5 years. Based on that, extract the requirements in terms of the functional specifications. Based on functional specification, then you define the chip blocks which will be required. So what you need into the technology requirements. Based on the technology requirements, then you look at your process and blocks and various, we discuss about the various blocks and modules or a fresh IP creation. You start to design the chip, validate, verify. But more and more what we can see is actually all this additional stuff which is going on the chip, that would need the additional block at the hardware level plus also at the software level. So software is going to play obviously a very, very important role, because we think that always the hardware is once designed, it will remain as it is for its period of life. Some of the chips for automotive we make 10 years or 15 years life, we promise. So today we release the chip in the market, we tell our customers, okay, 10 years, 15 years, I will supply you. Because that's what they want, right? However, going forward, there will be few things, those will also be managed and controlled by software actually. You will have multiple blocks on the chip itself, may not be everything enabled. You have the software which is running on top of that, which manages this thing actually. So this is how things will unfold. And it's pretty complicated obviously, and that is why every company may not be successful. There are few companies those would be successful. Overall in general, some companies will be successful overall in a particular niche market. Right? They will take one particular niche vertical and they will run after that and they will be successful. May not be everybody. So it's like all 5 fingers are not equal. Same thing in our semiconductor field, every company is not equal. They might have strengths, everybody will say that I have a process technology, I have my customer acceptance, I have this and that, but they are not as successful as another one into every marketplace actually. So this will depend how the things are done, and something would also be based on what finally happens. You can forecast and predict something, but not necessarily that will happen. It happens, many cases. Out of 10 cases, 8 cases will be successful, 2 cases things may not happen as you expect from the market side. But no problem on this. This is part of the game.
Perfect. So where is Freescale falling in?
So actually, if you look at our merger of Freescale with NXP, this has been very, very strategic merger actually, and there is a lot of synergy. We have a very, very little overlap. So if you start to look at the various portfolios, you will see that more than 90% of the portfolio is non-overlap actually. So that's a good news for our customers, because now they don't get confused. And second, it's good news for the companies also, they don't have much of a headache as what to choose and what not actually. So that way the merger is very, very strategically placed, very good. Overall, globally, worldwide, most of our customers are happy with that this merger is not disrupting them. But also we have worked out approaches which call as a cross-breeding or cross-selling. So there are many processes and technologies what we have, and as well as Freescale, this combined together. Now we are much better placed, we are much better equipped to add value to our customers and create difference to the customers. So right now the strategy within company is to really look at this combined stuff, and we are going to the customers now that we offer you a solution now, rather than selling your product. That is one device and this device, let this microcontroller and take this radar chip. Instead of that, make a complete solution and tell them, the customer, that now here is a solution which can help you to reduce your development cycle time, which can help you reduce the size of your board, which can help you to reduce the cost of the overall design. So that way we are offering the additional value to the customers, and that is where many customers are quite happy over there. So this is, we have just completed the merger recently, and this is progressing quite well worldwide in each country and each location. And we see that in future we are much more better placed, and our customers would get delighted with what we offer actually as an additional value to them. At the end of the day, that is what needs to be done actually. Finally, we clearly believe it's more of a customer focused passion to win. That means the customer must be happy. We must get more than what others are offering, otherwise you are no place to do. And that is the focus right now within our company, that consolidated everything, right from the portfolio, making it to the solution oriented, right from the people, making them customer oriented, right from all the manufacturing facilities, to create that operational excellence, create that synergies, so that we cut down the overall cost wherever it is possible, to bring additional value, bring additional functionality, bring additional technology, and make that available to the customers, which finally makes available to the society and to the consumers. Finally, that is where the change has to happen.
So from a product oriented, it's going to become more like an end-to-end solution.
We are looking at a solution oriented, clearly. From a product oriented company, it is going through the solution oriented.
Is this customer change driven? Because I think this is a trend. Startups are rather more of looking at solution based.
So we see this is not only question of the customer driven, we see it's a market requirement, let's say, in the sense that now customers are also hard placed. And at some point of time, they were doing everything on their own. And as improving the value chain, it is all the more necessary and important that the various stakeholders in the value chain, they increase their value, and overall as the ecosystem squeeze everything in terms of the overall cycle to market, in terms of overall the size of the design, in terms of overall cost, and bringing additional functionality and other things. So that becomes very, very important actually. Now it is very easier said than done. Many people, what they do when there is a solution, they make one simple piece of paper, put a block diagram, and say that this is block 1, block 2, block 3, this is I do, this is I do, this is I do, the rest of the things you can bring by here and there. We are going beyond that actually. We are really looking to that, build those interconnect, build those connections, build those synergy of various devices, make some reference designs, make some proof of concepts, and then go to the customer and say that now this is what we have, where we can put additional value for you, where you can create a difference to your end consumers. NXP, after the merger with Freescale now, is world's fourth largest semiconductor supplier in the non-memory space, and world's leading supplier in the automotive semiconductors.
Okay.
With operations around 35 countries, sales turnover of about 10 billion plus, 11,000 strong engineering force, and 9,800 patents. We are clearly looking forward to the customer-focused passion to win. So working very clearly towards the technologies, processes and products, moving them into the solutions and trying to add value to our customers so that they can create differentiators for themselves while they face their consumers.